In this lesson, I will talk about relations, the definition and different notations for relations, as well as look at a few graphs. Let's start with the definition. A relation is a set of ordered pairs. Its graph is a set of points in the plane. This first graph is a sketch of a relation that contains a finite number of points. A relation may also contain an infinite number of points, as in the second graph. Using roster notation is one method for describing a relation. In roster notation, the elements of a set are listed one by one. This relation contains the elements or ordered pairs -1, -4, 0, -3, 1, -2, 2, -1, and 3, 0. To sketch the graph of this relation, we begin by labeling the x and y axes. Then we will plot the points -1, -4, 0, -3, 1, -2, 2, -1, and 3, 0. The same relation can be written in set builder notation. Set builder notation gives a formula or rule to follow. In set builder notation, this relation is defined as the set of ordered pairs x, x minus 3, such that x equals -1, 0, 1, 2, or 3. Using the formula x minus 3, along with the first x value of -1, I'll have -1 minus 3 equals -4, giving us our first ordered pair -1, -4. Note that this is the same as the first ordered pair in our roster notation. The x values of 0, 1, 2, and 3 will produce the remaining 4 ordered pairs in the roster. Roster notation seems simpler here, but in many cases set builder notation is preferable, as you will see in the next few examples. Note that this relation contains a finite number of ordered pairs. The graph contains a finite number of points. Let's try graphing the relation, the set of ordered pairs x2, such that x is greater than or equal to -3. To be included in this relation, x coordinates must be greater than or equal to -3. Some x coordinates that would be included in this category are x equals -3, x equals -1, x equals 0, and x equals 2. The corresponding y coordinates will be 2 for each of these, resulting in the points -3, 2, -1, 2, 0, 2, and 2, 2. But x does not have to be an integer, so let's include the points -1.52 and 1/3, 2. Including all points with x values greater than or equal to -3 and y coordinates of 2, we have what is called a horizontal ray with endpoint -3, 2. Note that this graph contains an infinite number of points. Next, we will graph the set of ordered pairs -3y such that -2 is less than y is less than or equal to 4. Again, I'll start by labeling the axes. The x coordinates for all points on this graph will be -3. What about the y coordinates? Y takes on values between -2 and 4. So let's see what that looks like. Okay, it looks good, except for we need to pay a little more attention to those endpoints. Y is strictly greater than -2, meaning that at the point -3, -2, we need to put an open circle. And we can see that at y equals 4, this point will actually be included. Y is less than or equal to 4. This is a vertical line segment. Try this next graph on your own. After sketching a graph of the set of ordered pairs -1y such that y is less than 3, describe your graph. For this last example, let's look at a graph that has been sketched and determine a formula that describes the shaded area. If we choose a point in the shaded area, we can see that it must have an x-coordinate greater than or equal to -1, as indicated by the dashed line x equals -1. There are no restrictions on y-coordinates, so we can choose any ordered pair xy as long as x is greater than -1. Our relation is defined as a set of ordered pairs xy such that x is greater than -1. This is the graph of a half plane.